The drone industry is booming, and is projected to grow even more in the next several years. One of the applications of this technology our team learned about and immediately became interested in is photogrammetry. The problem that we recognize is that drone photogrammetry systems are incredibly expensive, usually costing several thousands of dollars. Our solution is TED. Responsible for Subsystem 1, we have Kevin Chang. Responsible for Subsystem 2, we have Steven Sattler. And finally, responsible for Subsystem 3, we have McCrae Wattenshire. TED is a quadcopter that we custom built to lower the cost of photogrammetry tasks. TED will fly above a target location, acquire data with 2 cameras and a variety of sensors, then after flight employ a post-flight processing algorithm to generate a topographical map. The Power and Stability Subsystem's battery will ensure that all electronics on the drone have sufficient power, and the ESCs will ensure that the motors are receiving the proper PWM signals. The gimbal will reduce vibrations caused by the motors and automatically adjust orientation so the camera is at a consistent angle relative to the target. As you can see, the gimbal will compensate for any instability the quadcopter will experience during flight. The Sensing Subsystem is dedicated to acquiring data. TED's GPS module is used to add spatial accuracy to the topographical map. The PXF sensor board has a gyroscope, accelerometer, and compass, all of which are used for image correction and post-flight processing. The receiver allows for wireless control of our quadcopter, and the Raspberry Pi is the brain behind the quadcopter, enabling everything else.
The purpose of the data processing subsystem is to take spatial data and images collected by the stereo imaging subsystem and relate them via similar points on the same object within both images. The difference in indices between these points is known as the disparity and can be used to generate a depth map. In order to calculate the disparity between cameras, the cameras must first be calibrated. Calibration is used in order to account for any distortions that may occur for each individual lens system involving each individual camera.
Here's an example of TED connecting to APM Planner. We first power up TED so that the PXF Mini can broadcast a Wi-Fi hotspot. We then connect to the hotspot using a laptop. After that, we click on the connect button on the APM Planner interface. If done correctly, it will display a success message on the screen. From there, we can then arm TED and he'll be ready for flight.